Hi, welcome to Maths with Shayem A. I am Shayem A. Please like, share, and subscribe. Let's get to today's lesson. Guys, today we are doing arithmetic sequence. The arithmetic sequence. Now, arithmetic sequence is the same as the linear number pattern that we did in grade 10. The linear number pattern. Now, why do we say this is linear number pattern or arithmetic sequence? It is because we get it by actually it has a first common difference. It has a first common difference. We are going to take an example. Let's look at the pattern 3, 7, and 11. Like that. Now, if we check the difference, remember we calculate the difference by taking term 2 and subtracting term 1. So term 2 in this case is 7 minus 3, which gives us a 4. And then in this case we do the same. 11 minus 7 is also giving us a 4. So we can see there is a common difference of 4. So because it has a first common difference of 4, then we call this arithmetic sequence. Now, we are going to be dealing with this arithmetic sequence. So in general, if we want to generalize this, the first term number 1 of an arithmetic sequence, we just call it A. Maybe it's because it's the first letter of alphabet. Now, to get to the next term, we add the common difference. For example, we had term 1 as 3. Now, to get to term 2, we are going to take that 3 and add, excuse me, we are taking the 3 and add the difference, which is 4, so we get a 7. So hence that is how we got the 7. So now to get to the next term, to get to term number 3, we are going to take term number 2 and we add the difference, which is said it's 4. So in other words, we'll have the 7 and we add the 4. That's why we have 11. So we can do that with all the terms. So now, if we are going to generalize, we will say term 1 is A, term number 1 is A, and then to get to term number 2, we will say it is term number 1 plus the difference. So if we want term number 3, we will say it's term number 2 plus the difference. So in other words, term number 2 we said is A plus D, then plus the difference. So we can see now that we have what? A plus 2D. So that is term number 3. So term number 3 is A plus 2D. So meaning we can do the same with term number 4. We will say is term number 3 plus the difference. In other words, it will be A plus 2D plus the difference, which actually gives us A, excuse me here, A plus 2D plus the difference. So in other words, we'll have A plus 3D. Right, so this is term number 4. Therefore, we can look at this and generalize that the general term, if we want the general term, like for term of any term there, so can you see that if it was term 1, it was a plus how many d's? Plus 0d, no d, because it's 1. Term 2, it's a plus 1d. It's just 1d. Term 3, it's a plus 2d. So it was a 3, now it's a 2. Term 4, it's a plus 3d. So 4 and a 3d. So in other words, out of nowhere, if we want term 100, if we want term number 100, we will just say it's a plus, because it's 100, then we'll just say it's 99d. So therefore, if we want the general term n, so n represents any number, it will be a plus that number subtract 1d. So this is the general term of an arithmetic sequence. Now we are going to look at what we can do with this general term. I want us to start with the difference. What can we do with the common difference? So we are going to look at questions that may arise using the common difference, the D. A practical example, we may be given, let's say, take an example. We are given 3 terms with an unknown. Let's say the unknown is x. So we have the term x plus 3, and then we have 5x minus 1, and we have 7x plus 1. Now, we are given that these are the first 3 terms of an arithmetic sequence. It must be stated otherwise. Otherwise, so these are the first 3 terms of an arithmetic sequence. And we want the value of x. We want to determine the value of x. So because we are told that this is arithmetic sequence, so we are going to use what we know about D. So remember, to get the common difference, we are going to take term 2 and subtract term 1, which is actually the same as term 3 minus term 2. So we are going to do that. We are going to take term 1 and subtract term 2, so that we can get the value of the common difference. If we are given x plus 3, 5x minus 1, 7x plus 1. So they say these are the first 3 terms of an arithmetic sequence. These are the first 3 terms of an arithmetic sequence. So we want the value of x. So in order to get the value of x, we are going to use that common difference. That's why we use the D. Now remember, we said D, or common difference, we get it by taking term 2 and subtracting term 1, which is the same as taking term 3 and subtracting term 2. So if we have to substitute here, we say term 2, which is 5x minus 1, subtract. Now, when we subtract more than one term, we must remember that we have to open bracket. So otherwise, we are going to make mistakes there. So we need to open bracket. So we are subtracting term 1, which is x plus 3. So this equals to term 3 is 7x plus 1. And then we are subtracting term 2, which is 5x minus 1. So we should remember to make a bracket. So we are subtracting 5x minus 1. So now we can remove the bracket. we have 5x minus 1, then a negative times x is negative x, and negative times 3 is negative 3, equals to the 7x plus 1. And then we subtract this, we remove this bracket, so it's going to be minus 5x plus 1. So we can take like terms together, we can solve for x. So we have 5x minus 1 here is 4x. And here 7x minus 5x is 2x. So bringing the 2x this side, it will be minus 2x, equals to this side we have 1 plus 1, which is 2. And here we have minus 1 minus 3, which is minus 4. We bring it that side, it will be plus 4. So in other words, we have 2x equals to 6. Now dividing both sides by 2, we will have x to be 3. So we got the value of x. So this was just an example of how to use the D. Now we are going to look at where do we use the term n. The term n, which we said is a plus n minus 1d. We're going to look at the examples of questions where we can use the term n, which we said it's a plus n minus 1d. Now, let's take, for example, a pattern. Say we have 5, 12, and 19. And there are so many terms there, and let's say that's a 2, 2, 2. Now, we want to know how many terms are there. How many terms are there in the pattern? Another way of stating this, we can talk about the 222, and we ask the question, which term is equal to 222? So in other words, which term is that? Which term number is 222? So this is the same as how many terms are there in the pattern. So this statement as that and that statement, they mean the same thing. This is the same question. So we are going to use our term n to answer such a question. So we say that this 222 is the nth term, is a particular term. So we say term n is 222. At the moment, we don't know which term number is this, but we know it's a certain nth term, because if we know 5 is term number 1, 12 is term number 2, 19 is term number 3, but we don't know which one is this one, so it's just the nth term. So now we say term n is 222. So, but we know the formula for the general term. So term n, we know that it's a plus n minus 1d. So this is 222. So we are going to use this to know how many terms are there. So now let us substitute what we have. The value of a is the first term, which we can all see that it's 5 from this one. And then the n is what we are looking for. And d, let's calculate d. d is the difference. So remember, it's 5, 12, and 19. So 12 minus 5, it's 7. And 19 minus 12, it's 7. So it means our difference is 7. So we put it there and then we start calculating. So this is 2, 2, 2. Now taking the 5 that side, we have n minus 1 into 7 equals to 2, 2, 2 minus 5. So 2, 2, 2 minus 5, it's 2, is what? 2, 1, 7. It's 2, 1, 7. So it is 2, 1, 7. So we have a choice here to remove the bracket first, or we can just divide by 7 both sides. So if we divide by 7 both sides, we will have n minus 1 equals to the 217, and we divide it by 7. So this is giving us 31. So now we can take the one that side. So in other words, we can have n equals to 32. As I said, one can remove the bracket first and have 7n minus 7 equals to 217, and you take the 7 to the other side, and then you have 7n equals to 217 plus 7. When it goes that side, it will be plus, so it will be 2, 2, 4. And now you can divide both sides and you get n to be 32. So in other words, there are 32 terms. There are 32 terms in this number pattern, or in this pattern. So, or meaning 222 is term number 32. So this is how we use the term n formula. So we can use the term n formula to calculate the value of n. Which term is that one? Now I'm just going to give another example of how to use the term n formula. Right, so for example, in an arithmetic sequence, we have an arithmetic sequence. Now, in this sequence, we are given two terms. We are given that term number 8, let's say they say term number 8 is 23. And again, we are also given another term. Let's say they give us that term number 29, it's 86. So we are given term number 8 to be 23 and term number 29 to be 86. And we want the sequence. In other words, we want term 1, 2, and 3. So we want to calculate the first 3 terms. Right, so this is another example of where we are going to use our general term. Now, from where we have done, or what we have done here, we remember how to get term number 8. So if it's 8, we can write it as a plus 7d. So that is term number 8. So in other words, term number 8 is 23. So you write it as equals to 23. But if you have forgotten this, that term number 8 is a plus 23, you can start with your general term and say it's a plus n minus 1d, and start substituting. They want term number 8, put 8 there, so you write a plus 8 minus 1d, and you come back to a plus 7d. Right, and then that is term number 8. And we are also given term number 29. So term number 29, it's a plus, because it's a 29 here, we will have 28d. So that is given to be 86. Right, so now we want the first 3 terms. So now we have two equations. We have equation 1 and we have equation 2. So we also have two unknowns. So we can apply simultaneous equation so that to get the value of A and D. So we did different ways of doing simultaneous equations in grade 11 and in grade 10. So the best here is elimination. We can eliminate the A. So in other words, we can take term 2 and subtract term 1. So if we take term 2 and subtract term 1, A minus A is 0. 28 minus 7 is 21. 21D. And then 86 minus 86 minus 23 is 63. So in other words, 21D equals to 63. So we can divide by 21 both sides. Can divide by 21 both sides to get the value of D, which is 3. 63 divided by 21 is a 3. So we now have the value of D. So we can get the value of A. We can substitute in any of the two equations. We can substitute in any of the two equations. The first equation is A plus 7D equals to 23. We can substitute in this one. Excuse me. 7D. This one is A plus 29D. Okay, so A plus 7D equals to 23. So we substitute the value of D. So we have A plus 7 times D, we said is 3. This is 23. So we have A plus 7 times 3 is 21, which is 23. So we take the 21 to the other side, and we get our A to be 23 minus 21, which is 2. So if we have A and we have D, we can get any sequence because we know that A is term 1. So it means term number 1 is A, which is 2. To get to the next term, we can just add the difference. The common difference is 3. So 2 plus 3 is 5. And then to get to the next term, we can take the 5 and add the difference. So 5 plus 3 is 8. So we have our sequence as 2, 5, and 8. So you see, this is how we can use the term n in arithmetic sequence. We can use it for many other things, as we will be looking at other examples that will follow in the next module. But now we must familiarize ourselves with this arithmetic sequence. What is this arithmetic sequence? How do we calculate the common difference? And what can we use the common difference for? And what can we use the general term for? So I am just going to take one last example where we can use this general term of an arithmetic sequence. I'm going to take a question here. It says that in an arithmetic sequence, arithmetic sequence, in an arithmetic sequence, the seventh term exceeds the fourth term by 15. In an arithmetic sequence, the seventh term exceeds the fourth term by 15. So determine the value of D. Determine the value of D. That's number one. So, and maybe number two, let's say this is question number one, this is question number two. Question number two, determine the value of A if term number 7 equals to 13. Now we are going to look at this. This is another example of where we can apply the general term n equals to a plus n minus 1d. So let's look at this. We have our question. Now, we know we are dealing with an arithmetic sequence. In an arithmetic sequence, the seventh term, let's write term 7. So term number 7, we know that it is a plus 6d. That is term number 7. And what else do we have? They say the seventh term exceeds. To exceed is to be bigger than. So the seventh term is bigger than the fourth term by 15. Okay, let's have the fourth term. What is term number 4? Term number 4, we know that it's a plus 3d. So in other words, term number 7 is bigger than term number 4 with a margin of 15, or by a margin of 15. So in maths, when we do sequences and series like this, we don't want to be dealing with greater than. We want to be dealing with equals to. So we want to equate the two. So we will say a plus 6d, which is the seventh term. We want it to be equal to the a plus 3d, which is the fourth term. So, but we know that they're not equal. They said that this one is bigger than that other one by a margin of 50. So for them to be equal, we have to add the 15 to the smaller one. Or if we wanted, we could have subtracted this 15 to term number 7. So now, because we have added this 15, it means this statement and that statement are equal. So the statement on the left and the statement on the right are now equal because we have added that 15 that they said it exceed by it. So in this case, now we have the right to put the equal sign there. So we can now start solving. So if you look at this, the a coming this side, it will be minus, so it will subtract the a. And then we are left with the 6d. The 3d coming this side, it will be minus 3d. And we are left with 15 this side. So we actually have 3d equals to 15. And then dividing by 3, we get the value of d to be 5. So that was number 1. So we have determined the value of d. So that was question number 1. We now go to question number 2. Determine the value of a if term number 7 is 30. So in other words, we are going to have term number 7, which they said equals to 13. According to what we said term number 7 is a plus 6d. So this is 13. So we substitute the d that we calculated here so that we can get a. So a plus 6 times d, which is 5, is 13. So we know that 6 times 5 is 30. So we will take it that side. 13 minus 30. We take the 13 and subtract the 30. So we can get 17. So in other words, the value of A is 17. Right, so that is another example of using the general term. Now we know when and how to use the general term. Let's meet me in the next module where we will be looking at summation. But thanks for now. Please don't forget to like and subscribe. Thank you very much.